Just close your eyes for a second. Imagine a world with absolutely no light, nothing. No sun, no light bulbs, not even a candle. Just complete darkness. You couldn't see anything at all. Not your own hand in front of your face, not your friend sitting next to you. You couldn't even see yourself in a mirror. That's just how incredibly important light is to our world. So today, we're going to dive right into this amazing world of light, shadows, and reflections. We're going to find out exactly how light travels, why you can see a reflection in a mirror but not on a wall, and hey, maybe even figure out what it takes to make the perfect shadow puppet. So, here's our game plan for this journey. First, we'll cover the basics of what light actually is. Then we'll look at how it interacts with objects to create shadows. After that, we'll unlock the secrets of mirrors and reflections, check out some really clever inventions, and finally, we'll wrap it all up by seeing why light matters so much in our lives. Ready? Let's go! Alright, first things first, let's tackle the biggest question of all. What exactly is light? And where on earth does it come from? So, at its simplest, light is a form of energy. Think about it like this. The only reason you can see a book right now is because light from a source, like a bulb, is hitting the book, bouncing off it, and then traveling straight into your eyes. It's that little journey of light that lets us see the world. Now, where does all this light come from? Well, we can pretty much split the sources into two big groups. You've got your natural sources, things that are just out there in nature, like our sun, the stars, and even fire. And then you've got artificial sources, which are all the man-made things, like light bulbs, candles, or the torch on your phone. But wait a minute, what about the moon? Does it make its own light? A lot of people think so, but nope. The moon is actually like a giant dusty mirror hanging up in the sky. It doesn't produce any light of its own, it just reflects the light from the sun back down to us. So the moon isn't a light source, it's a reflector. Pretty cool, right? Okay, so we know what light is and where it's from, but now let's get into how it actually, works. Let's see what happens when light bumps into different objects and how that creates something we all know and love. Shadows. So light follows a few very strict rules. Rule number 1, it always travels in a perfectly straight line. We call these lines rays. Think about a laser beam. It's always straight, right? Rule number 2, because it travels straight, it can't just bend around things. It's not going to curve around a corner to find you. And rule number 3, we can see things only because light bounces or reflects off them and into our eyes.
Now, not everything treats light the same way. We can sort objects into 3 types. First, you have transparent things like a clear glass window, which let all the light pass right through. Then, you have translucent objects like a frosted bathroom window that lets some light through but scramble it all up, making things look blurry. And finally, you have opaque objects like a wooden door that block all light completely. Go on, take a look around you right now. Can you spot one of each? And this brings us to shadows. A shadow is really just a patch of darkness created when an opaque object gets in the way of light. It's actually a pretty simple recipe. All you need are 3 things: a light source, an opaque object to do the blocking, and a screen or a surface for the shadow to fall on. That's it. You've definitely noticed this, haven't you? Your shadow seems to have a mind of its own during the day. In the morning, it's super long and stretched out. Then, around noon, when the sun is right above you, your shadow is just a tiny little thing. And then, in the evening, it gets all long and stretchy again. It all depends on the angle of the sun. Low sun, long shadow. High sun, short shadow. Simple as that. Alright, enough about blocking light. What happens when light bounces back? Yup, we are moving on from shadows to reflections. This is all about how light bounces off surfaces to make images, especially those super clear ones we see in mirrors. So when light rays hit a really smooth and shiny surface, like a mirror or even a calm lake, they all bounce off in a very neat and tidy way. every single ray bounces off at the exact same angle it hit. It's a super organized bouncing that creates a perfect clear image that you can see. But what about a rough surface like a wall or a piece of paper? Well, when light hits that, the rays go flying in all directions. It's a total mess. This is called diffuse reflection. It's why we can see the wall itself, but because the light rays are all jumbled up, they can't form a clear image, and that's why you can't check your hair in your textbook. Now, mirror images have a couple of really interesting features. First, your reflection is always the same size as you are in real life. But second, and this is the weird part, it's laterally inverted. That's just a fancy term that means left and right are flipped. Go ahead, try it. Stand in front of a mirror and raise your right hand. Your reflection will raise its left hand. It's the exact same reason the word ambulance is written backwards on the front of the vehicle, so that drivers looking in their mirror can read it the right way around.
So now that we know all these rules about how light works, let's look at how people have used them to build some really clever gadgets. We're going to check out two: the super simple pinhole camera and the very sneaky periscope. A pinhole camera is basically just a box with a tiny hole in it. And here's the magic. Because light travels in straight lines, the light rays from the top of an object, say a tree, go through the hole and land on the bottom of the screen inside. And the rays from the bottom of the tree go through and land on the top. The rays cross over and the picture you get is completely upside down. It's so simple but so smart. You know how in submarine movies they use that tube to look above the water? That's a periscope, and it works using two mirrors. Light comes in the top and hits the first mirror, which is set at a 45-degree angle. Boing! The light bounces straight down the tube. Then it hits the second mirror at the bottom, which is also at 45 degrees. Boing! Again, the light bounces right into your eye. It's a brilliant way to see around corners or over walls. Okay, for our last section, let's get to the big question. Why does any of this really matter? First off, get ready for a number that will blow your mind. Light travels at 300,000 kilometers per second. That is so fast that a beam of light could go around the entire Earth 7.5 times in the time it takes you to snap your fingers. There was literally nothing in the entire universe that's faster. It's the ultimate cosmic speed limit. And light is absolutely essential for life. I mean, plants use it to make their food through photosynthesis. And without that, we wouldn't have much to eat. All of our cool technology, like cameras and telescopes, are built around controlling light. Sunlight helps our bodies make vitamin D to stay healthy, and of course, the most obvious one, it lets us see the beautiful world around us. So, let's do a super quick recap. The big things to remember are: light is energy that travels in straight lines. When it's blocked, it creates shadows. When it bounces off smooth surfaces, it creates reflections. This can lead to cool things like inverted images. And most importantly, light is absolutely essential for all life on Earth. So, I'm going to leave you with a little challenge. The next time you see your shadow on the ground or catch a reflection in a window, just pause for a second. Think about all the amazing science that's happening right in that moment. The world of light is all around us all the time.